Hello everyone and welcome back to this next lecture. So this is where we had left off in the previous lecture where we had compiled our driver.lib project, and with both projects compiled we are now ready to execute these projects. So at this point of time I'll bring the microcontroller into the video. So you can now see the microcontroller in the video, and here it's pretty much the same, except now because we have a full bridge converter I have now 4 connections for each CPU. So in this case, I'm connecting A and B outputs of EPWM1 and 2 to the solderless breadboard, and A and B outputs of EPWM4 and 5 into this solderless breadboard. So now that this is done, initially the connections have been made such that channel 1 of the oscilloscope is connected to A output of EPWM1, which is corresponding to switch S1, and channel 2 is connected to the B output of EPWM1, which is corresponding to switch S2 or device S2. So I'm just going to zoom in on the oscilloscope so that that's all we need to see. And with this we can now enter the debug mode. So first I will go to the debug mode in the Bitfield project. And the project has been loaded, so all I have to do is click on it and click on the continue button. So now look at the oscilloscope waveforms, and you will see we got similar waveforms even with the half bridge DC to AC converter, right? So this is essentially the phase angle changing from 0 to 2 pi, as a result of which the modulation signal is a cosine waveform that is changing as a cosinusoidal waveform from -9 to +9. Right? So therefore, as it changes, the width of the pulses is going to change from the maximum to the minimum. So now in this case, you can see that the yellow waveform and the blue waveform are complementary, and the reason for that is because yellow waveform is the gate pulses to the device S1 and the blue waveform is the gate pulses to the device S2. So now to verify our theory, I'm going to now connect the blue waveform, that is channel 2, to S4. And now you can see that the waveforms are identical. So which means that the gate pulses that are being provided to S1 and S4 are the same, and that is expected because here the diagonal devices are conducting together. So now let me connect S2 and S3 together. So now the yellow waveform is S2, and now because it is S2 and S4, you will see that these are again complementary with respect to each other. So now I'm going to connect the blue waveform to S3, and you will see once again these are identical, and they are identical for the simple reason that these S2 and S3 are also diagonal devices which operate together. So this therefore confirms that we have achieved bipolar PWM. That is, the output of the full bridge converter will be either plus VDC or minus VDC. Now with this I'm going to come over here to CPU2 and let's execute the project there. So first we connect the target, and then I will load the program. So the program has been loaded. I'm going to click on it and click on the continue button. So the oscilloscope is still in the same one, which is here, which is what you call it in EPWM1. So I'm going to change it over to CPU2. So now I'm connecting yellow waveform to A output of EPWM1 and the blue waveform to B output of EPWM4. Right? So therefore now we are connecting it to devices S1 and S2, and once again you see they are complementary. So once again I will move the blue waveform to device S4, and you will see that these are now identical. Sorry, this is not blue. Yeah, this is now S3. So now they are identical. So this is now the connection between S1 and S4. And as you can see, these are now identical. So now I'm going to connect S2 and S3, and they are also identical. Right? So this therefore proves that we have achieved bipolar PWM. So with this, I am going to now end this microcontroller video. And I have also come to the end of this lecture. So here I will leave this to you as an exercise that you can comment out the statement where the phase angle is changing, place the phase angle of both CPUs in the watch window, and make only those particular and provide different values to the phase angle to verify that the gate pulses are the way you would expect them to be. So this I will leave to you as an exercise. So with this, we are now done with the very first PWM strategy with respect to the full bridge module. In the next lecture, we will start with the unipolar PWM strategy. So if any of this did not work or you faced any other issues, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture. Thank you so much for listening and see you soon. Goodbye for now.